The next case is concave mirror again, but the position of the object is between focus and pole. So if I happen to keep the object here, right, let's see what happens. So I'm trying to draw a small object. Can you see that? It's for a reason. You'll understand why in a minute. So we have the incident ray parallel going through the focus. Then you can take one more incident ray, which appears to be coming from center of curvature. Okay. So basically you can do this. So this is your incident ray, reflected ray. Incident ray, reflected ray. What do you observe? These are diverging. It's neither parallel or converging, it's diverging. So what does it mean? If you project the lines back, okay, something like this, and something like this. If I project the lines back, that's not a good thing. Not good again. Okay, that looks promising. So if I happen to project the line back, this is your point of intersection of those imaginary lines. See, these are dashed lines. Remember, we spoke of dashed lines. Dashed lines are one wherein you have a imaginary line. Actual lines are solid lines. Okay, these two difference you need to know. So this is where your image appears to be so. Again, this is not actually the image. It's just a projection in the mirror. So it looks to be enlarged. Okay, it looks to be bigger. It's erect. It's behind the mirror. Right? This cannot be captured on screen. That is, this is virtual. Right? So what else you need to know? Size is enlarged. Okay, so pretty much this is what it is. So never ever forget to draw dashed lines behind the mirror. Right? So how do you do this practically on a sheet of paper, that is? So as usual, we'll start with a 15 centimeter or more line. So next is, okay, I'm trying to figure out, we need to give a bit of gap, is it not? Because the image is behind the mirror. So I kept some space, 0, 3 and 6. Next is drawing an arc, same set of steps, no difference. Next thing is indicate that it's a mirror. Right? So I'm going to take an object. Try to draw small and try to write near pole. I don't know why I took it near focus. That was my mistake. It's not that you won't get the answer. It's just that it will be, you will get to see. So take a ray which is parallel to principal axis. It takes some time to get adjust and everything. Right? It's okay to do that. Turn your book around, pages around. So we have your parallel incident ray. So what happens? It will pass through the focus. Don't forget to project it back at the same time. Don't lift your pen, right? Don't lift your pencil, that is. Try to project it back as soon as you guys finish drawing that. Then I'm trying to figure out from center of curvature how it looks. So I just realized what I did. Well, you'll get to see that. So that's your ray, right? Diverging ray. So I'm drawing that. So that's your line of incidence, and then that will get reflected. It's just for you guys to see that. That's why I did that. Okay, so next thing is we need to project it. See, the mistake I made is the projection happens way back because I took the object near the focus. I should have taken it a bit nearer to the pole. And the point wherein this dash line meet is where your image is formed. So it's a pretty big drawing, but yeah, that's not, it is right. This is also right. Nothing wrong in that. So again, I'm putting all of this as dash lines. Remember, it is practically not possible for the light to pass through a mirror, right? I mean, if it's a good mirror, it doesn't happen. There's no hole and all of that. So all of this has to be represented with dash lines. And yes, you don't should not forget to label FP. This is your AB and A dash B dash. So what is the size? Size is enlarged. Orientation, erect. It's the upright, right? This is virtual. Clearly, this cannot be projected onto a screen. Location, behind the mirror. Okay, let's look at it practically. So what did we see? This was my object. I mean, I just made it out of the uh, cello tape kind of thing which I had. So this was, you saw that this was your plane mirror and this is your concave mirror. So basically, plane mirror, you could see how close it was actually. It's not that I took it close, it was that far itself. But you can clearly see it got enlarged, right? It is erect, it is it is enlarged, then it's behind the mirror. It cannot be projected onto a screen, right? We are pretty much done. So where can we use this? We pretty much use it in quite a few places, and you guys would have not imagined we use it over there. Dentists use that, dental purpose, right? When they have you seen that? They keep a mirror kind of thing. If not, next time you observe that. Okay, so dentists use this as shaving mirrors. You know, beauticians use this. I mean, I'm writing shaving mirror, but it is used for basically making your face look big. You know, where else can you see? In theaters, not the normal theaters, I'm talking about acting theaters. Then any beauty wala setup, they will have this. Okay, that's basically your concave mirror, right? So what else? Yeah, this is virtual. Don't forget that this cannot be projected on the screen. Okay, so this is something that you guys have to copy now.